Scientific theories are coherent explanations or interpretations of one or more phenomena. Now, phenomena are those general results that have been observed reliably in systematic empirical research. And typically, theories go beyond the phenomena that they're based on by including variables, structures, processes, functions, and organizing principles that have not even been observed yet, at least directly. Now, the word theory is kind of problematic. When you're talking to scientists, there's no confusion. But as soon as you go outside the laboratory and you begin talking about your theory with non-scientific individuals, now they aren't going to understand you. The word theory outside of scientific circles tends to imply this idea that we're talking about something we're not sure of. We're talking about something that hasn't even been tested. It's just like a wild guess, basically. But that's not at all what it means. You know, every time we talk about a theory in science, we're always talking about an explanation of phenomena, an explanation or interpretation. In other words, we have seen it, we have evidence, and here's how we are going to explain what we've seen. It's not at all a guess. It's not at all a shot in the dark. I mean, sure, there could be theories out there that haven't been tested yet, but most theories that you'll see have been extensively tested. They've been developed over years and decades and maybe even centuries of research. So typically, 99 times out of 100, whenever we bring up the word theory, we're talking about something that has a lot of support behind it. And the word theory isn't the only one that tends to be confusing amongst non-scientific individuals. There's a few other terms as well, such as perspective. So when scientists use the word perspective, they're referring to this broad approach to explaining and interpreting phenomena, which is typically more general than the common theory. Another term would be model. So this is a very precise explanation or interpretation of a specific phenomenon. So this would be like the polar opposite of perspective. Very, very specific. And it's often expressed in terms of equations, computer programs, or biological structures and processes. And then you have the word hypothesis, which is an explanation for a phenomenon that relies on only a few key concepts. And unlike the term theory, a hypothesis is generally a little bit more than a guess. You know, it does have some observation behind it, but when we call something a hypothesis, what we're saying is we haven't really tested this out yet. You know, it seems to be legitimate, but we still need to test it. And basically all a hypothesis is just a prediction for what we expect to observe under certain conditions. Now, in science, theories are used for all kinds of purposes. The main purpose, of course, is to try to provide an explanation or interpretation of phenomena. But there are alternate uses as well. Like some theories completely fail to explain or interpret phenomenon, but they're still useful. You know, these theories serve another purpose. So the three additional uses for theories are organizing what we know, organizing the known phenomenon, predicting the outcome of new situations, and generating new kinds of research. So that first one, organization, this is in fact one of the most important purposes of scientific theory, to help us organize phenomena and help people to think about them and communicate more efficiently. So theories are good. We consider these kinds of theories good if they can help us to organize both the phenomenon, the primary phenomenon we're interested in, and other phenomenon as well, if it falls in line with what's called the principle of parsimony. This is the whole idea that the theory should only include as many concepts as are necessary to explain and interpret the phenomenon of interest. In other words, if this theory can explain multiple phenomenon in a very simple way, then it is a very good theory. That second purpose, prediction, this just refers to how researchers can, try to figure out what will happen in new situations. Say, for example, you're a gymnastics coach that wants to know whether a student will perform better during a competition than when practicing alone. Well, if you think back to drive theory, you would be able to predict that the student's performance will, in fact, suffer during the competition if she is not confident in her capabilities. So if she makes a lot of mistakes during her practice sessions, those mistakes will only become more serious and more numerous during the competition. And then that third additional use for theories is generating new research, raising new questions. And this is one that I was briefly mentioning earlier, when I was talking about how theories can still be useful even if they're not accurate. This is the one I was talking about. So Sigmund Freud, for example, I don't mean to throw him under the bus entirely, but Sigmund Freud, for example, he generated a lot of research. He's still generating research to this day, even though all of his original theories don't seem to be very accurate whatsoever. We haven't really been able to scientifically validate any of his early psychological theories. So even if a theory is inaccurate, that doesn't mean it can't spark some good ideas in other people. And if those original theories are unverifiable or they're just bad, eventually they will be abandoned. But the whole point is, bad ideas can still be interesting. Now, humans are annoyingly complex. At any point in time, researchers are usually considering multiple theories for any set of behavioral phenomena. In fact, different theories for the same phenomenon can also either go together in a complementary way or compete with one another. Like maybe each theory could provide an explanation of a different aspect of the phenomenon. Or perhaps one of these theories is simply more accurate than the other, or more parsimonious than the other. There's often the case where you have multiple theories all trying to explain one thing, but one of them is simply the best. But we're never satisfied. Just because it's the best theory we have so far, that doesn't mean it's the best theory we'll ever have. Remember, there is no such thing as truth in science. All that we have is the best explanation so far. And researchers are always trying to verify that their explanation is the best. We're always comparing our theories with each other to try to see which ones are the best when it comes to organizing phenomenon, predicting outcomes, and generating new research ideas. And those theories which are considered less useful or less accurate are eventually just abandoned. They're never completely rejected, but they're just abandoned because they're not as good as the stuff we have nowadays. That's just how technology goes. So all I'm trying to say here is no real scientist, no honest scientist would ever say that their theory is the final answer. It is the true explanation. All we can ever do is provide a pretty good explanation of what we understand so far.